Hi everyone, welcome back. In today's lecture, we will discuss about basic concept of electrotherapy part 2. In previous video, we had discussed part 1 of basic concepts in electrotherapy. Today we are going to discuss further concept in the basics of electrotherapy. So we will discuss about a capacitor or a condenser, then about inductor, then a very crucial concept known as the magnetism, and then about electromagnetic induction. So let's discover into each of this topic in detail in this video. As the first one, let us discover about a capacitor or a condenser. One peculiarity about most of the topics that we discuss as the basic concept in electrotherapy is that most of these topics you might have learned in the previous classes in your school life and most probably in your plus twos. You might have learned more depth in physics about it, but we don't need that such deep concept. We just need to brush up the ideas and have a very brief idea on some of these topics. So what is a capacitor or a condenser? Do anyone remember what is a capacitor? A capacitor is a device that is used to store charges. So for example, we have consider the example of a water tank in your home. What is the purpose of that water tank? Use water tank to store water. Similar to that, the capacitor is a device that is used to store charges. So one peculiarity or the important function of a capacitor is that it helps in storing the charges. So it is mostly made up of two metal plates which are separated from each other with help of an insulating material. For example, consider this as one metal plate and this one as another metal plate. So both of these metal plates are separated from each other. They are not attached together. They are separated from each other with the help of an insulating, not a conducting, with the help of an insulating material. That material is known as dielectric material or dielectric constant. So most of the capacitors are made up of two metal plates which are separated each other with the help of an insulating material known as dielectric material. So how do you define capacitor? Capacitor is a device that is used to store charges. They consist of two metal plates separated with the help of an insulating material. So this metal plate, imagine its positive polarity, it's positively charged, this one is negatively charged. So if there is no insulating material, what happens? You cannot store charges. This two of the materials can come together. So what we have is an insulating material that separates both of this material, both of these metals, and helps in storing the charges on this one and this one individually or separately. So what happens is that if that insulating material is present, the charges get stored. So you can store charge in a capacitor as and when required. The capacitor can dissipate or give away that charges. So that is the function of capacitor. And the unit of capacitor is known as capacitance is known as the what you call farad. And 1 farad, usually we don't express in terms of farad, but we express in terms of microfarad, where 1 microfarad is 1 in million of a farad. But we also need to understand what is capacitance. Capacitance is nothing, it's just the property of the capacitor. So the property of the capacitor to store charge is known as the capacitance. So that are the important things that you need to know about capacitor. Then an equation of the charge stored in a capacitor can be given by charge is equal to the capacitance of that object or the conductor into the voltage. So charge is represented by Q, capacitance by the capital C, and voltage by V. So Q equal to C into V. So these are the most important things that you need to know. So capacitor is used to store charge. Two metal plates are separated by a medium known as the dielectric, and basic unit is farad. Capacitance is usually expressed in microfarad, which is 1 in millionth of a farad. It holds electric charge when and when required and dissipates the charges or gives up the stored charge when the situation comes or when the need is there. So this diagram just represents a capacitance. The figure 2 is the way in which you draw the circuit for a capacitor, or you represent a capacitor circuit. And here you can see in the diagram, which is like a battery, you can see the white lines, or the white ones known as the metal plates, two metal plates. In between you can see that orange colored dielectric material. So what happens is that this dielectric material helps in storing the charges when and when required. So the charges can be stored in the capacitor. In capacitance, the capacitance in series is often denoted by, do you remember the equation for resistance in series? It is R1 plus R2 plus R3. Here capacitance in series is represented as 1 by C1 plus 1 by C2 plus 1 by C3, and capacitance in parallel is opposite to the series one, which is C1 plus C2 plus C3. You don't need to remember it, but it is well and good if you can just at least understand that the equation. We are not going to use the equation and find out the capacitance of an object, anything like that, like what we used to do in the physics lectures or physics classes. So that's is the concept of capacitor. Let's see, why do we need capacitor and what is the need of this discussion in electrotherapy. And there are two types of capacitor. One is a fixed capacitor and a variable capacitor. You know, a fixed capacitor is just two leaves, two interleaved metal plates with air as the dielectric medium. So in fixed capacitor we just have interleaved metal plates. Two metal plates will be there, only two metal plates will be there, and they are separated by air as a dielectric medium. Whereas in variable capacitor, the term variable denotes it. What happens is that there are different sets of metal plates. This is one set of metal plates, another set of metal plates, similarly different sets of metal plates attached together. So what happens is that when you increase or decrease the distance between these metal plates, of course you can increase or decrease the charge that is stored, as well as you have a knob, something like a knob which can turn off some of the what do you call sets of metal plates. This type of what you call capacitors are seen in shortwave diathermy, etc. So you know that the knob that we are using in shortwave diathermy, it's all the applications of capacitor. So that is why we need to learn all this concept, because most of the electrotherapeutic devices works on the basics of this electricity and basis of this physics. So this type of capacitors are used in various devices like MRI machines, CT scan machine, X-ray machines, in electrotherapy like shortwave diathermy machines, in EMG analysis machine, in like what you call in different filters that we use in electrotherapy, like low pass filter, high pass filter, band filter, etc., and in various oscillators and timers. So what are the uses of capacitors? Capacitors are used to filter circuit. They are used to allow the passage of alternating current, whereas block the direct current, as well as to store the charges. The main function is always storing the charge, but at the same time they help in passing of the alternating current and AC, as well as blocking the DC, and also helps in filtering different circuits. So that is the concept of a capacitor. And now we move on to the inductor, which is the inductance, which is not much importance on capacitor. You just need to understand the basics of inductor. Inductor is a coil of wire. Inductance or inductor is a coil of wire that resists change in electricity passing through them. Inductor is a coil of wire that resists changes in electricity that passes through them. It is used to store energy as magnetic field, whereas capacitor was storing energy as electric field or electric potential difference. Here, the inductance store energy as a magnetic field. It is often denoted by the SI unit Henry. That is the SI unit of inductance. It is used in transformers, chocks, and more different motors, etc. And the unit is, as I told, the Henry. So what is an inductor? It is a coil of wire that is used to store energy in the form of magnetic field, and it resists any change in the electric current that passes through them. So that is known as the inductor. Let's see more in depth into the inductor. Here you can see a diagram where the capacitance or a capacitor is shown, which store potential energy as energy in the form of electric field, whereas an inductor, you can see this diagram, you might have seen this inductor in different electric modalities or electric devices. If you had a chance to open the example, for example, you can see something like similar in the fan in some TV circuits, etc. So what happens is that here energy is stored in the help of a what do you call the magnetic field, that is the inductance. So inductance of a coil, so it is a coil of wire, you know that it's a coil of wire, so that inductance is dependent on various properties. Can you tell me some of the properties? You can just guess on the property. The number of a coil, more coils means more the inductance. Then you know that I can wrap a coil on the top of my hand like this. So the core, the inner material on which the what do you call the coil is being wrapped on. So that is very important. The type of wrapping, different type of wrappings are available, are seen. So it depends upon the type of wrapping. Then the length of the coil, how long is the coil, is it a long one or a short one, the cross-sectional area of the coil. So these are the various factors in which the inductance of a material depends. You just need to simply understand it and just note down the points in the number of the coils, the type of the wrapping, the core on which the wrapping is done, the cross-sectional area on the wrapping, the cross-sectional area of the wrapping, and as well as the length of the coil, as well as the number of layers of winding. The number of layers of wrapping is also important. So these are the various factors in which inductance of a inductor do depend upon. So two concepts we have discussed. One is the concept of capacitor and inductor. Most important one is the capacitor when compared to inductor in exam point of view. Here you can see a series circuit in inductor, again series circuit in an inductor, and a parallel circuit you can see, and different type of inductors that we use have been shown in this diagram, like molded inductor, air wound inductor, iron powered toroidal inductor, ferrite core inductor, variable inductor, etc. Just for your understanding and just for the what do you call, just to have a simple understanding. That's it. No need to study any of those names, to be frank. Like, so now we need to discover, or we are going to understand a very simple concept which we could not discuss in basic concept part 1, that is the concept of conductor, insulator and the semiconductor. I think I don't need to discuss it at all. Conductor is a substance or a material which enables the passage of electricity. For example, all the metals, for example, iron, silver, aluminum, etc. All of those materials allow the passage. Insulator do not allow the passage. You know that plastic, glass, etc. are the examples of insulator. Semiconductors, their conductance to the electricity lies between insulator and a conductor. So example is germanium and silicon, etc. So a very basic idea, just to brush up your ideas. That's it. Most important concept that we need to focus on today's discussion is the concept of magnetism. So what is magnetism? They might ask you this in your vivas or as a short note question in different exams. So what is magnetism? Magnetism is a property of a material, or magnet is a material which produce magnetic field. So that's a simple definition. So magnet is a material that produce magnetic field. So what is magnetism? Magnetism is a force of nature produced by moving electric charges. So magnetism is a force of nature produced by the moving electric charges. So that is very important. Definitions is not much important, but the concept that we are going to discuss in the following sessions are much important. So what are the properties of magnet? I'm pretty well sure that all of us have played with magnet. We had different type of magnet in our childhood, and sometimes even we see the kids nowadays playing with magnets, but mostly the previous generations, so we used to play with magnets. Nowadays kids play with what you call the mobile phones. So what are the properties of those magnets? Can you just correlate? So magnets always arrange in north-south pole direction. Whatever way we keep it, magnets arrange in north and south direction. The same poles of the magnet, north pole and south pole. You know that magnet contains two poles, the north and south poles. The same poles repel each other, and unlike poles attract each other. So north pole and north pole repels each other, but north pole and south pole of a magnet attract each other. Magnet has a property to transmit its magnetic property to the materials which it comes in contact. Suitable material, not all the material. For example, you can see that if you take a magnet to some what you call a test full of what you call some iron core or iron. So what happens is that when you place the magnet on it, all the iron particles just get attracted to that, and some of these particles also gets a property of magnetism, at least for a short while. So it has the property of transmitting the magnetic property to suitable material, as well as it attracts the suitable materials. Example, the iron that I described, it did not attract the sand, but the iron in the sand, iron particles in the sand, the magnet attracts, and magnets produce magnetic field. All the magnets produce a magnetic field in and around the magnet. So these are the different properties of magnets. It's important, to be frank. Let's see again into the properties of magnet through this diagram. Magnets attracts objects made up of iron, nickel, etc. You can see the second diagrams. You can see the poles of the magnets. Poles always exist in pairs and they cannot be separated. So the poles always exist in pairs, north and south poles, and poles attract each other. The opposite poles and same poles repel each other. You can see from these diagrams, opposite poles of the magnets attract each other and same poles repel each other. And if a magnet is suspended freely by a thread, it always aligns in north and south direction. That's why magnetism or magnet was used in helping with the direction in earlier generations for sailing and so on. That's not much important. So something else that is important again is magnetic lines of forces. They might ask you, what are the properties of magnet? It's very easy. So what are the properties of magnetic lines of forces? So what are this concept known as magnetic lines of forces? Any idea? Magnetic lines of force is nothing but an imaginary line that exists in between or exists around a magnet. So magnetic line of force is an imaginary line representing the direction of magnetic field. So it is a imaginary line which helps or represents the direction of the magnetic field of an magnet. It doesn't exist, but it's just imaginary line. Okay, so what are the properties of magnetic lines of forces? A short way to understand is magnetic lines of force is the property of magnets. So the properties of magnets are the properties of magnetic lines of forces with some difference. Let's discover the properties of the magnetic lines of forces. Magnetic lines of forces are closed curves. The first important thing is magnetic lines of forces are closed curve. Let's just look into this diagrams. You can see that the magnetic lines of forces are closed curves, and direction is always from north to south pole, not from south to north pole, but always from north to south pole, because that is the orientation of the magnet. No two magnetic lines of force can intersect each other because they are charged lines. So not two magnetic lines of force can intersect each other. Magnetic lines of forces converge, contract longitudinally and disperse laterally or dilate laterally. Magnetic lines of forces contract longitudinally and dilate laterally. The diagram again illustrates the same. So what are the concepts that we have discussed? Magnetic lines of forces are closed curves. Magnetic lines of force starts from north to line south pole. So that are the important things that we have discussed so far. And then crowding of the magnetic lines of force represents a strong magnetic field. So if a magnet, if we can represent the magnetic fields as too many crowded, then that means it's a strong magnetic field. There is a strong magnetic field. Whereas if it is having less number of magnetic lines, or they are like what is imaginary line, but still if there is a large number of imaginary lines or large number of lines, it shows the strong magnetic field. And if it is represented by less number of lines, it's show meaning that it contains less magnetic field. And the tangent to the magnetic field always gives the direction of the magnetic lines of forces, direction magnetic line, magnetic field at that point, which might have discussed, you might have studied in your plus 2 session. It's not important how to calculate the tangent and what is the tangent over here. Just understand these are the different properties. Even if you cannot remember all these properties, at least remember very few properties, a few of them, which is very easy. Like magnetic lines of forces have closed curves, magnetic lines of force cannot intersect each other, magnetic lines of forces always travels from north to south pole, magnetic lines of force contracts and distally they become they dilates laterally and contracts longitudinally. Crowding of the two magnetic lines of force means that they are having strong magnetic field, and not crowding means it has less magnetic field, etc. Right? And now we see another important concept, which is known as the electromagnetic induction, which is the last topic in today's discussion. So what do you mean by electromagnetic induction? The phenomenon of generating electromotive force, EMF. Okay, you might have heard about EMF in your law classes. So the phenomenon of generating EMF by changing the number of magnetic field or magnetic lines of force associated with a conductor is called electromagnetic induction. So the phenomenon of generating electromotive force by changing the number of magnetic fields associated with a conductor is known as electromagnetic induction. It's a means by which electricity is produced from magnetic field or magnets. For example, we have a coil of wire and a magnet. If we bring the magnet and the coil of wire together, and if we move the magnet from and to the coil of wire, to inside the coil of wire and outside, this motion can help in production of electricity. So this is known as the electromagnetic induction. So it's a phenomenon of generating of electromotive force by changing the magnetic lines of forces. By changing the magnetic lines of forces is known as electromagnetic induction. For the example is, in a coil of wire, if we are bringing a magnet to the coil of wire and moving away from the coil of wire, if this motion continues, if the motion takes place, it helps in generation of electricity. It is a means of producing electricity from the magnetism. Results from interaction between a conductor and a magnetic line of force, which we have discussed already. And then there is important thing to know in the electromagnetic induction. People may not ask you, because examiners may not ask you what is electromagnetic induction. It's less likely, but they might ask you one important question: what is Lenz's law? What is Lenz's law? So the Lenz law is also known as law of electromagnetic induction. So let's describe what that law is. EMF induced in a circuit is such as to oppose the flux change rising to it. Flux change means the direction or the amount or the quantity of the electric charges that passes through it. Okay, that is just the concept of flux charges, but you can't define law in your own word. You have to describe how the Lenz's law is being defined. So EMF induced in a circuit is such a way that to oppose the flux change that is causing that, what do you call, the EMF induced. So EMF induced in a circuit is such as to oppose the flux change that is rising to it. So that is known as the Lenz law. Let us describe that with the help of a diagram. So you can see here in a coil of wire is shown, a circuit is shown, and a magnet is brought from north to south direction. So what happens is that you can see that the arrows that is representing the current flow or the EMF induced, if the magnet is moving in one direction, the EMF induced will be in such a direction which is opposing that flow of charges which produce it. You can see in the second diagram, you can see if the magnet is moved in opposite direction, so the orientation, the arrowhead of the charges also changes. So that is known as Lenz law. An induced current always flow in a direction such as to oppose the change which produce it. Electromagnetic induction. So an induced current always flow in a direction in such a way that it opposes the change which it produces. That is known as the Lenz's law. You all do not need to draw the diagram, explain Lenz's law, but you just need to understand Lenz's law. So you might need to study different laws like Ohm's law you have already studied, Coulomb's law, Lenz's law, inverse square law, different laws. But how to remember the Lenz's law? Is that related to electromagnetic induction? So electromagnetic induction or EMF arising from a conductor is in such a way that it opposes the flux change that produces it. Remember in that manner. And then induction can be of two types. One is known as self-induction and mutual induction. That's only one that we need to study. That is self-induction and mutual induction. Let's see what it is. Self-induction is a phenomenon due to which a back EMF is induced in a coil as a result of change in current arising in it. Self means it's related to one particular coil itself. So EMF is produced in a coil as a result of change in current that is flowing through it. Mutual induction is a phenomenon in which induced EMF is set up in a set of coils when current flow through the neighboring coil changes. So self-induction is related to one particular coil and mutual induction is related to two or more sets of coils. So that's most important thing that you need to remember. I don't suggest you studying the definition of self-induction and mutual induction. Even if you understand that electromagnetic induction is the phenomenon, this one you know how to define Lenz's law, and you just need to understand there are two types of induction, that is the self and mutual induction. Need not remember the what you call the definition, it's not much important, but still let's just simply brief it. It's a phenomenon due to which back EMF is induced in a coil as a result of change in current flowing through it. Change in current flowing through one particular conductor itself or an inductor itself produce the self-induction. If two sets of coils are there, it producing what you call mutual induction. So that are the different concepts that we discussed in today's video. One is the capacitor or condenser, then the inductor, electromagnetic induction and magnetism, as well as some concept of conductor, insulator and semiconductor. In this, magnetism is very important. You need to remember it. In this, one particular law is very important. I'm focusing on that in exam, for example, in your practical lessons and viva exams, etc. So that is the Lenz's law. So that's all about today's video. And if you like the video, don't forget to click the like button and let me know your comments on this video. I'll see you next time.